A tsunami is defined as a series of water waves that is caused by the large displacement of water, typically in an ocean, that often results because of earthquakes or other disturbances. In 1963, at an international scientific conference, the word tsunami was adopted as a common word, with tsu meaning harbor and nami meaning wave in the Japanese language. Don't get the word tsunami confused with other terms though. Tides are caused by gravitational influences such as other planets, the moon, or the sun. Tsunamis, on the other hand, are often generated by earthquakes, landslides, volcanic eruptions, or even meteorite impacts. Seismic waves often are caused by earthquake-related reactions. Tsunamis, although they can be generated by earthquakes, can also be caused by other disturbances as well. All seismic waves are tsunamis, but not all tsunamis are seismic waves. As indicated, tsunamis are quite often caused by earthquakes. So how can earthquakes generate tsunamis? Well, Earth's crust is like a spherical puzzle that's made up of many individual tectonic plates. These plates can push together, move apart, or even slide along each other on fault lines, which are regions that divide these plates. When these plates press together on the fault lines with their jagged edges, they end up building up a lot of pressure, which eventually causes the plates to slip along the fault lines. This creates an earthquake. When these two plates suddenly slide across each other, seismic waves are created, which either travel over Earth's surface, called surface waves, or into Earth, called body waves. When these waves move through Earth or reach a surface, they often shake the ground, causing what is known as an earthquake. When plate tectonics underwater suddenly slip over each other, a bulge and deformation of the seafloor is created, which encloses a lot of energy. When the plates end up moving when an earthquake occurs, the plates transfer this energy into the water. Because of the vast amount of earth that is displaced, waves are formed as the water attempts to regain its equilibrium position, acting under the influence of gravity. Energy in the water is thus transferred. This allows for the occurrence of a typical tsunami condition. The initial tsunami size is determined by many factors, the main one being the amount of deformation of the seafloor. This amount is primarily controlled by the depth of the faulting as well as the earthquake's magnitude. Enough about earthquakes. How about other disturbances that displaces a large volume of water from its equilibrium? Submarine and subaerial landslides often occur as a result of an earthquake. When sediment moves across the seafloor, the sea level equilibrium often alters, which results in a tsunami. Debris that has fallen displaces the equilibrium of water and also results in a tsunami. Volcanic eruptions can also create an initial perturbation for water displacement and can produce a tsunami. So how are tsunamis characterized? In shallow water waves like a tsunami, the period is much longer, from 10 minutes to 2 hours. The wavelength is also very long, at around 500 kilometers. There is also a small ratio between water depth and wavelength. To calculate the speed of a tsunami, the square root of the product of the acceleration of gravity and water depth can be used. The energy lost in a tsunami is inversely proportional to the wavelength. Because the wavelength is long, little energy is actually lost when it travels. This means that tsunamis can advance far distances and still can be catastrophic. When tsunamis begin to enter the more shallow waters near the coast, the water depth decreases, the tsunami speed slows, and the height increases, as shown in the diagram. The total energy change remains constant. Thus, it can reach over 30 meters in height as it approaches shore. So how do tsunamis impact coastline ecosystems? Tsunami waves often carry a lot of debris as they move inland, including cars, boats, trees, or even people. Often they extend inland more than 300 meters. In addition, damages to flora, fauna, and coral reefs often occur when the waves go inland. In places such as Indonesia, the coral reefs take years to rebalance from tsunamis, and coastal tree plantations may also be severely destroyed. Salinization is another devastating consequence of tsunamis, which makes the soil unable to support vegetation as it becomes unfertile. It also increases more susceptibility to soil erosions, food insecurity, and largely impacts climate change. Humans are also affected both economically and ecologically. The loss of infrastructure in some fishery industries are just some unfortunate repercussions that we have to face.
Created using Powtoon.